Alright, today's problem is check if it's a straight line. So this problem is mostly mathematical, but there is a little tiny programming twist at the end. So let's imagine we're walking in a straight line. So for it to be a line, we must have started from somewhere. This will have a coordinate of x1, y1. And now we're walking towards some place. So this will have x2, y2. And now the question comes, given a third point, which is x3, y3, how do we know if that point is on the line that we're walking on? Okay, so we can break down this path that we're walking on into two components. The vertical component, so our change in y, which is equal to y2 minus y1, and our change in x, which will be x2 minus x1. Now given a point, for example here, or maybe here, or maybe here, how do we know if this is on the same line? Well, let's say that this is one step. If it's on the same line, that means we can take some amount of steps to get there. So for example, what we'll have is from our starting position, x1 plus, so one step is a change in x distance, plus our step change in x times some amount of step is going to give us to our destination x3. So similarly, if this is on the same line, then y1 plus our change in y times the same amount of steps is going to get us to reach to y3. So for example here, maybe we took 2 steps to get to here. Here maybe we took half a step, and then here maybe we took a step backwards to get to this position. Okay, so let's do some algebra. We're going to isolate for this s here. So we have s is equal to x3 minus x1 over change in x, and then s is equal to y3 minus y1 over change in y. So now we can set them equal to each other because they're both equal to s. So we can do something like that. Okay, so that means given a point x3, y3, if it's on the same path that we're walking on, then this equation has to be satisfied. If it's not, then it's not on the same line. Okay, so the little programming twist at the end that we want to do is instead of doing this, which includes division, so that means if we do division, let's see, these are all integers, right? So when we do something like 3 divided by 2, instead of getting 1.5, we are going to get 1 because of truncation. Right, so that means if we wanted to do this equality check, we would have to cast it into floats. But then with floats, we have stuff like floating point rounding errors, and like equality becomes a little bit harder. I'll leave a link below to a computer file video that explains it in more detail. But anyways, our goal is that we want to avoid floats if we don't have to use them. So what we can do instead is we can just do one more step of algebra and just shift this over here, shift that over there, and turn this into multiplication. So now we have x3 minus x1 times change in y is equal to y3 minus y1 times change in x. And now because everything is integer, this is an integer, this is an integer, and it's a simple integer equality check, which is much better. Okay, let's try coding this out. So at first, they guarantee us that there's at least 2 points. So let's make our path. So we have int x1 is going to be equal to coordinates at the first point for the x coordinate. Y1 is equal to coordinates at the first point at the y coordinate. Then we have x2 at, let's see, first point x coordinate 1, 1. Okay, so that means our change in x is equal, so we can change this a little bit. This is y2 minus y1, and this is x2 minus x1. Okay, so now we read the rest of the rest of our coordinates. So we'll start from the second, since we already read the first two, so we can start from the third. So I less than coordinates dot length. And now we have our int x is equal to coordinates at the ith coordinate of 0, y. Okay, so now we want to make sure that this equation holds. So if, let's see, x minus x1 times y minus y1, oh no, y2 minus y1 does not equal y3, so y minus y1 times x2 minus x1, then we can return false. Otherwise, if every single point passes this, then we can return true at the very end. Okay, let's see if I made any mistakes. Cool. Alright, well, that's it for today, and I'll see you on the next one.